Hi everyone. In this chapter 26, we will cover vision and optical instruments. In the lecture 1, it will be about vision and how we correct the vision in our eye. And in this chapter, we will see these concepts. You can read over. This is the cross section of the eye, and it's an amazing optical device. It receives the light and focuses on retina, and we can see things. So you can see the parts of the eye and which part is responsible for which purpose. Okay, this is a more cartoonish way of seeing it. In terms of optics, the cornea does most of the focusing, and the lens it gets elongated or shrinked, and its central thickness changes, thus the focal point changes, and we can actually the focusing point, we try to make it every time on the retina, and by changing the focal point of the lens, we can see different objects at the different distances. So as when our eyes can overwork or underwork, or we can have long or short eyeballs, depending on the situation, our focusing may not be perfect. So then we need to adjust the focusing of the eye by additional lenses or glasses. So there are two concepts here: near point, and which means the closest distance we can see or our eye can focus clearly. For the normal person at age 20 and so on, the distance is about 25. Far point is the farthest distance we can see, and normally it's infinite, at the infinity, compared to 25 centimeters. So we have two main not disease, but a problem: nearsightedness and farsightedness. Nearsightedness means we can see the near very well. See the near very well, not the far. So which means that the far point is too close. It's not far enough. The far point is too close. The farsightedness means see the far very well, but not the near point. So near point is too far away. So it cannot see the near, but it can see the far better. Or when you can, for example, for nearsighted, we also call myopic eye. Either we can have too long eye, or cornea is too sharp, or lens is overworking. For the farsighted, we can have a short eyeball and the eye focuses behind the retina, or our retina is not, or cornea is not focusing enough, or our lens is underworking. So these are the fundamental causes for nearsighted and farsighted eyes. So this table shows how the near point changes by the age. At early age, our eye can see the near very well. Near point is about 7, 10, 14 centimeters. But as we get older, our eye works less. It cannot focus well. So our near point gets longer. So let's say see how we can correct these nearsightedness and farsightedness. So nearsighted eye, it can see the near very well, or it can focus too much in front of the retina. So think about it, like if your lens is overworking, it's focusing, so you need to add something defocus. So what we use is diverging lens to reduce the focusing power of our eye if we are nearsighted. For the farsighted, it's the opposite way. Our lens is not working enough, so we help it by adding a converging lens, and we can focus exactly on retina. So that's how we can distinguish two not nearsighted and farsighted eyes, and how we correct with diverging and converging lenses. We have two additional um, vision problems. Presbyopia, it's a reduction or accommodation ability to be able to focus on the cornea. So and the astigmatism, this is about the lens is focusing X and Y direction in different rates. So that's why we have a kind of asymmetric focusing. So we need to have we can correct it by additional curvature on the lens, and then image will be symmetric on the retina. So this is one simple test to detect astigmatism. You can try. Okay, diopters. When we go to an eye doctor, when they prescribe glasses, usually they define as a focusing power, P, and it's called diopters. And what it is the inverse of the focal point. So let's say if you have a glasses with the focal point 100 centimeters, it means it's 1 meter, and the power P is 1 over F, 1 over 1 diopters. And let's say if you have minus 25 centimeters focal length or the glasses, the power is going to be 1 over F, and it's going to be in terms of meters. Minus 4 diopters. So this is how you find the diopters, just the simply inverse of the focal length in meters. So we have one example here. It gives, it's a far-sighted eye, and it's for big eye, and we are, and the near point is 100 centimeters. So which means that it can see the images or the objects at 100 centimeter best. It cannot see the closer objects very well. So the person wants to see the objects at 25 centimeters. So the question asks what kind of lens we should use to correct this far-sighted eye. So the purpose is you are not changing anything on the eye, but what you need to do is you need to place object image at 100 centimeters. So if we apply a lens formula, 1 over the object plus 1 over the image equals 1 over f. So object is at 25 centimeters, and image, it's going to be 100 centimeter, but it's the same side of the object, not the right hand side of the lens. So it will be minus 100 centimeters. So actually the figure is given minus 100 centimeters. It's going to 1 over f. So it's going to be 1 over 25 minus 1 over 100. 4 minus 1, 3 divided by 100. And the focal point is going to be 100 divided by 3, 33.3 centimeters. This lens will correct this far-sighted eye, and it will be able to see the objects at 25 centimeters. Okay, another problem is about nearsighted eye, and it says the far point of certain myopic eye is at 50 centimeters. Normally it should be infinity. What lens should be used to focus sharp an object at infinity? Okay, and it says the neglect distance between eye and lens, so we are assuming this is just so close to each other. So in this case, similarly, we are not gonna do anything to eye. What we are gonna do is we are gonna put the object at infinity at 50 centimeters. So we can apply the same formula. Now the objects at infinity, 1 over infinity plus, and the image is going to be on the same side of the object, so it will be minus 50 centimeters, and it will be 1 over f. So you need to be careful, the image is not on the right hand side, it's on the left hand side, which is the same side of the object, so that's why we put the negative side at here. So what you find, 1 over infinity is 0. Then what you end up is minus 1 over 50 equals 1 over f, and focal length is minus 50 centimeters. So you see that for correcting the myopic eye, we use diverging lens, and our focal length is negative. For the far-sighted eye, we use converging lens, and we find the focal length positive. So it's a self-check. So how we see the colors, we have different type of cone cells, so they are sensitive to different colors, basically blue, green, and yellow. For example, when you see a green laser light, even if it has the same power with the red light, you see a very bright spot, because our eye is very sensitive to the green. And the colors, for example, white light containing all the colors reflects from the blue object. It absorbs all other colors but the blue, and for the red objects all the colors but red. For white object it reflects all the colors. For the black objects all the light is absorbed, so there is not much light coming back to us. That's why we don't see a color. So that's all for this lecture. So we will continue the vision instruments in the next lecture, and we will have example problems in other lecture.